What is going to be the limit of this function as x approaches 9? Well, the first thing we try is direct substitution, which simply means if x is approaching 9, what happens when x is exactly at 9, or x is equal to 9? So that means the numerator, we're going to find that it's going to be 9 minus 9, which is going to equal to 0, and the denominator is going to be the square root of 9 minus 3, which is going to also equal to 0. So it's going to be 0 divided by 0. What's the problem? Well, you can have 0 be in the numerator, but you cannot have 0 be in the denominator. That's illegal. You can't divide by 0 in math. So direct substitution doesn't work here. So we're going to have to instead try a different strategy. Now, the next thing you should try is factoring or reducing. Can you factor or reduce this function in any way? Or in other words, split this into multiple brackets that each contain an x that can maybe cancel with something in the denominator in this case, because the problem is the denominator. We're dividing by 0 in this case. Can we change the denominator or cancel it out in some way to get rid of this division by 0 problem? And the answer is no. There's no real way to factor out, for example, in the numerator, an x to the power of 1. You can't do that. And similarly, in the denominator, you can't really factor out the square root of x into anything. So that's not going to work either. So we're going to have to create a new strategy. The third strategy we're going to have to create is going to have to be rationalizing. Now, why do I say rationalizing? Well, when you see something like a square root in your limits, you should immediately think, well, maybe I'll have to rationalize the function, or in other words, get rid of this square root, because clearly that is going to be the problem here. So how do we rationalize this function? Well, we have to multiply this function by 1, because we don't want to change it, right? Changing the function changes the problem. So to keep the problem the same, we have to multiply it by 1. But what does it mean to multiply it by 1? We're not going to literally multiply it by 1. We're actually going to multiply it by something over that same something, or in this case, f over f. What is f going to have to be? Well, that's what we have to figure out. To rationalize a function, we have to use the property that a squared minus b squared is equal to a minus b times a plus b. So, as you can see, because we were trying to rationalize the denominator, we're just going to look at the denominator, the bottom part. Well, what does this look like? This looks a heck of a lot like a minus b. Okay, so that means we have to multiply it by a plus b. And what is that going to look like? Well, that's probably going to look something like this, the square root of x plus 3. So that's going to be our f. So that's what we're going to try and do to rationalize this function. So let's go ahead and do that. So when we do this, we know that this is definitely just 1 because it's something over itself. However, because we're using our rationality property here, we're going to find that in the denominator, we're going to actually get rid of this square root. Because we know that when we take a property like this, we're going to end up with the a. In this case, the a is going to be our square root of x, and our b, which is in this case going to be our 3. And we're going to get something that's going to be the square root of x squared minus 3 squared, which really is just going to give us in the denominator, it's going to give us something like x minus 9, I believe. Yes, it's going to be x minus 9. Okay, in the numerator, we're still going to have x minus 9 multiplied by the square root of x plus 3. And we can put brackets around the denominator as well. And this is still going to be a limit as x approaches 9. Now, what do we know? Well, we're able to cancel our denominator, which is exactly what we wanted to do before, right? So we can cancel x minus 9 here with the x minus 9 there, and we're going to be left with the limit as x approaches 9, which is going to equal to the square root of x plus 3. Well, now we can actually plug in what happens when x is at 9. We can just say, okay, well, the square root of x plus 3 is going to be equal to the square root of 9 plus 3, which is going to equal to 3 plus 3, which is going to equal to 6. So, as this function approaches 9 in the limit, we're going to find that it's going to equal to 6.